Okay, for this video I'll be working through question 2 of the Level 2 2016 Mechanics exam. So, question 2, projectile motion. During a cricket game, a batsman hits the ball at an angle of 40 degrees with the ground at a velocity of 20 meters per second as shown below. Picture for reference. Show that the initial vertical component of the ball's velocity is 12.9 meters per second. So before we start that, I thought I'd draw a wee triangle just to make things a little easier. We'll make it big just because we've got space. Here's our triangle. It's a right angle triangle. This is our angle, 40 degrees. 40 degrees, and our velocity, I'm going to draw it along the hypotenuse, is 20 meters per second minus 1. Right, so show that the initial vertical component of the ball's velocity is 12.9 meters. So this is v vert and this is v hor, as in horizontal and vertical. So we have the hypotenuse, this is the opposite. So if we've got an H and an O, we're going to need to use SO, and if you know SOHCAHTOA, which is you should, that means we have sine theta is equal to, move this up a little bit, the opposite, which is v vert, divided by the hypotenuse, which the hypotenuse is 20 meters per second, 20 meters per second. Right, so if I do a little bit of rearranging, because I should have put the angle in but I didn't. We're trying to find out what v vertical is, but if we times both sides by 20, so I'm going to have 20 0 times sine, and I'm actually going to put the angle in now, it's sine 40 degrees equals v vert, which is the velocity vertical, and if you calculate that through, you get 12.856 meters per second minus 1. Notice this is a bit of a new thing for me actually. 3 significant figures, 3 significant figures, 3 again, 3 again. So our answer now needs to be in 3, but they've given it to us anyway, and this does actually equal 12.9 meters per second minus 1. That's something new for me. Right. Calculate the time it takes the ball to reach its maximum height. Right. So, final velocity, Vf, is equal to 0. Initial velocity is the vertical velocity, which is equal to Vi is equal to, I'm going to use the unrounded value just because it's not the actual answer, so 8, 5, 6, what else would I need to use? So, and acceleration is equal to 9.8 meters per second minus 2. I'm just going to double check, although I don't actually think. Where's my subject resources? Level 2. Have they changed the formula sheet at all? I can't find the formula sheet online. Right, so what's this? I'm using an old formula sheet, so this is a 2015, and they have acceleration is 9.8 meters per second. I need to double check this, but I assume nothing has changed, so I'm using that for now. And this is going to be a bit of area of a bit of conflict for me, which is a bit annoying. Right, so we've got that there. Let's just move this out of the way. Come on, who can see that? Right. Using your formula sheet, we got Vf equals Vi plus At. We're going to try to find time. So Vf equals Vi plus At. And let's quickly rearrange for t. So Vf minus Vi and then we divide by A equals time. Right, so we're going to plug that in, and that gives us, once we plug that in, 12.856 divided by 9.8 equals 1.316 seconds. I don't think this is the case, because I think when I originally did this previously, I used 12.9, but 1.316 seconds rounds to time equals 1.3 seconds. The reason, and this is the area I'm sort of a bit stumped on. I feel like NCEA probably made a mistake in the exam. It has to be 2SF, because you've used gravity as 9.8, so this has to be 2SF. In the answer schedule, I'm pretty sure it's 3SF. It's 1.32, but that's wrong. You can't have more significant figures than the least amount of significant figures that you've got. But anyway, okay, calculate the horizontal distance traveled by the ball before it hits the ground. So this is just the maximum height, because it goes up and then stops and then comes down. So your actual time, so time in air, or whatever you want to call it, time of flight, equals 2t, which equals 2 times this number, not the rounded number, equals 2.63 seconds. Right. And that's, so we need to work out the horizontal distance. Horizontal, I'm not going to write the whole horizontal, equals, okay, back to our triangle. We have the hypotenuse, we have, we're trying to work out the adjacent, so we're going to use, we've got A, we've got H, we're going to use cos, so we see that down here, cos theta equals the horizontal, so it's the cos theta equals the adjacent divided by the hypotenuse, so V horizontal adjacent divided by the hypotenuse, I'll just put 20, yeah, and if I rearrange that, it's the same as above, 20.0 cos 40 degrees equals 15.32 meters per second minus 1. Right. Well and good. So we've got the horizontal velocity. It's actually trying to find the distance. So distance is just equal to velocity times time, which is equal to 15.32 meters per second minus 1 times the time, which is 2.63 seconds, which gives us 40.29 meters. But the answer schedule either says 40.2 or 40.4, which either they've used 9.81, and then because they wrote 3SF for this, which should be wrong because level 2 is only 9.8. So there's a mistake there, and then they've rounded 3SF, but you can't do that because you've used gravity back here. So this has to be 2SF, which means this has to be 2SF. But for brevity, we'll put everything in. It should be a mistake, but whatever. So we round this to 3SF to begin with, 40.3, which is in the middle of what they had. They had 40.2 or 40.4 meters. And then 3SF, but really because we use 9.8, which is only 2SF, that uncertainty comes all the way through the equation. So the most accurate we could ever be can only be 2SF, so it should really be 40 meters 2SF, and that usually sticks with sort of the standard of level 2, only using 2 significant figures with all their exams. Right, give a comprehensive explanation to the effect of the forces or force acting on the ball during its flight. Assume air resistance is negligible. Good, so we can get rid of that. In your answer, you should describe the horizontal motion. Okay, so there are no forces in the horizontal direction because there's no air resistance. If there was, air resistance. Have I spelled that wrong? Yes, I have. Horizontal direction as air resistance. What's my spelling doing today? Resistance is negligible. Negligible. I'm a terrible speller. So horizontal velocity remains constant. Sweet. So no forces in the horizontal direction means horizontal velocity remains constant. If they have had questions before, you can have questions where air resistance isn't negligible, which means your horizontal velocity will decrease. It'll only decrease because air resistance always acts in the opposite direction of motion. It always opposes motion. Right. So we're going to talk about, so that's horizontal, done, vertical motion. So we're going to talk about the way up and then the way down. So on the, two doubles, the ball's ascent, A-S-C-C-E-N-T, I assume that's how you spell ascent, going upwards, gravity opposes motion. I don't know if I need that apostrophe or not. Opposes motion, causing the ball to slow down, and stop at the top. Stop at the peak of its flight. So the peak of its flight, at the peak of its flight. F-L-I-G-H-T. Right, so that's when it's going up. The gravity opposes on the descent. So on the ball's descent, gravity acts in the direction of motion, causing to a rate slash. So this is a little bit, I have to add a bit more to this. So on the ball's descent, gravity acts in the direction of the motion, causing the ball to accelerate. You can confuse that. Like, you can say something is accelerating with a negative acceleration, which is really decelerating. Well, no, let's just forget. So let's just say increase its speed. Just avoid confusion. Increase its speed. That is that. So vertical motion on the way up, yep. Vertical motion on the way down, and forces as well. So X in the direction, the only force is gravity. There are no other forces unless it's like a metal ball in a magnetic field, and there's no friction as well. So done, question answered.